In this problem, we want to find the maximum value of x times square root of 1 minus y squared plus y times square root of 1 minus x squared. Now, how do we approach this problem? Well, the big clue is that it's the form the square root of 1 minus y squared. This pattern, well, it just screams trigonometry. We can imagine a right-angled triangle with a hypotenuse of 1. If one of the short sides is x or y, then by the Pythagorean theorem, the other short side must be square root of 1 minus x squared. So this suggests that we can simplify the entire problem by reframing it with trigonometry. So let's define x and y using angles. We can let x equals to sine of A, and then y equals to sine of B. For the square roots to be real numbers, x and y have to be between -1 and 1. To get the biggest positive value, we can assume x and y are positive. So we can think of angles A and B as being the first quadrant, or in other words, between 0 and 90 degrees. Now, the square root parts can become cosines. Square root of 1 minus x squared equals to the square root of 1 minus sine squared A equals to cosine of B. Because we know that sine squared A plus cosine squared, cosine squared A equals to 1. So, in the same way, we can get that square root of 1 minus y squared equals to square root of 1 minus sine squared B, which is cosine of B. And then, we can substitute these back into our original expression to get sine of A times cosine of B plus sine of B times cosine of A. This is the sine angle addition formula. And we can simplify this. So this will equal to sine of A plus B. And then, this complicated algebraic expression has transformed to something more simpler, sine of A plus B. Finding the maximum value is not easy. The sine function, no matter what its angle is, has a maximum value of 1. So we can get that the maximum value will equal to 1. And that is how you solve this problem.